So objective 2 of the first topic is finding the domain and range of radical functions and then discovering their transformations and seeing how that affects the vertex of the given function. Remember in objective 1 we just talked through, we looked at the parent functions, y equals the square root of x right here, and y equals the cube root of x right here. And so we're going to finish topic 1, graphs of radical functions and their transformations. So we're going to call upon our familiarity now of the parent functions, y equals the square root of x and cube root of x, for this objective in this video. So to begin, because we're going to start graphing these a little bit, we're going to talk about the vertex, the most important part of the graph, because it begins at the vertex. And so all the transformations, for what I want you to know about transformations, is going to be based off of the vertex. And then we're going to talk about the types of transformations that exist, which should be reviewed because we talked about that in Module 2 and 3. And then I want to talk through the domain and range as well. So at the end of this video, you should be able to fill out a form like this, all right? And I'm going to do an example problem on your practice work, and then I'm going to have you do the rest of your practice work as well. All right, so to begin, the parent function y equals the square root of x. The vertex, again, which we mentioned in the last video, is 0, 0. The x and the y value. Same thing for the vertex of the cube root of x, 0, 0. And both of those are very important because you're going to be able to talk to me about the transformation of any given function based off of the vertex. And so if we get into the transformation function, this is the formula for it. Y equals the square root of x minus h plus k, where h and k are values of the new vertex. And so the vertex, again, is going to be, you see how it's minus h? And you can consider this radical to be the same as the parentheses we used in Module 2. If it's trapped inside the radical, it's lying to you. And so instead of a negative h, I'm going to write positive h, and then the k is telling the truth. So again, another way I've talked about that, here's an addition sign. Instead of before it was like x minus 2 squared plus 3, that's a quadratic, and I said to the left of the power is lying to you, if you remember that. Now it's just a radical sign, so to the left, inside the radical sign, is lying to you, to the right is telling the truth. And so keep that in mind. I'm going to write, and please keep note of this, h value is lying to you. Because that is very important, because you're going to have to find the vertex in every function in this objective. Alright, so the h value is always going to be lying to you. So again, just to review, the types of transformations are a horizontal shift, left to right, and it makes sense that a horizontal shift always has to do with the h value. So again, the first value in our vertex of the transformation. And let me make this visual known to you. This is technically the x value, and this is the y value as well. So the h is the x, k is the y. Alright? Just keep that in mind. The vertical shift is the k value or the y value. You flip about the x-axis if there's a negative. So let's say it's y equals negative square root of x plus 2 minus 3. That negative makes it flip about the x-axis, and I'll talk about that. And finally, a vertical stretch is y equals, if there's a number multiplying with the function itself, x plus 2 minus 3. This number would stretch it vertically by a factor of 2. So again, just a review there. So I want to talk, before I get into the examples I've given you, I just want to talk about how I can find the vertex of a given function. So if I write y equals the square root of x plus 4 inside the radical minus 3 outside the radical, the vertex of this, again, please make note of this. The way I visualize this is to the left of the radical. Again, let's say this let's say that this is the breaking point. To the left or inside the radical, the h value is lying to you. So it's a positive 4 here. The vertex is a negative 4 right there. And then to the right of it is telling the truth. Is a negative 3. So opposite 4 and then negative 3. So that is my vertex, and that's the process I want to be able to have you be able to do, is identify the vertex every time with the h value lying to you, the k value telling the truth. And this is my x and my y. So I could plot that and go with it, type thing. So please review how to find a vertex if that process isn't solid for you. Now let's look at some examples of finding the vertex and telling the domain and range of any given function, because this is what you're going to have to do in your practice work, along with stating the transformation in words. But if that's a review, so I'm just going to cover that briefly. So if I look at the parent function, the vertex of the parent function, again, we've already talked about this, is 0, 0. This is the x value and the y value, all right? So the domain is going to have a very specific relationship with the x value of the vertex. Again, for review, domain is x-axis, which means the x values, and it's left to right. The range is the opposite, y-axis, y values, and bottom to top. Always start with the floor, go to the ceiling. And we've talked about domain and range, but it's going to look a little bit different for radical functions, especially the square root. So the domain, I have to think of the leftmost point. And if you see, the leftmost point is a dot, and it's a closed dot, meaning that the domain includes that point that it's on. And so instead of a parenthesis, I have to show this by a bracket. All right, because that bracket signifies that this left part of my domain is going to be included in the domain. So you have to write a bracket if there's a dot on it. So that bracket, that dot, is the x value of my vertex. So the leftmost point of this domain is 0, the x value of my vertex. It makes sense because domain is x-axis and x values, all right? Then, this graph does indeed go on forever in the right direction. So the left value was 0 to the right, goes on forever to positive infinity. So it looks a little bit different, but it still should be pretty straightforward. And again, we don't include positive infinity, because it just goes on forever, so I use a parenthesis there. So that's the first way I'm going to write domain. The next way, and you need to get familiar with this as well, is that for all x values, all right, all x values, meaning all these x values that exist in this function that are going on and on and on forever in the right-hand direction, they're all going to be bigger, so I'm going to write greater than, bigger or equal to, remember, because it's included here, 0. So the domain of this, all x values are greater than or equal to 0. And remember, the greater than sign eats the bigger numbers. And so all these numbers are included, and they're all bigger than 0. So two different ways. This is interval notation, and this is inequality notation right here. Please become familiar with both of those. Now the range is pretty similar to the domain. I just have to find the y values. Now, I don't care about the x values anymore. I'll do this in green. I care about the y values. All right? So for the y values, I look at the y point of the vertex. If you notice, it is 0. And if I look at my graph up here, the lowest point, it stops. The floor stops out or bottoms out at the y value there of 0. And I can plot this again. This is x, this is y. So the lowest point is my y value because the range is y-axis, vertical, and y value. So the lowest point is my y value of 0. But, again, it includes 0, so I have to put a bracket because that dot at the vertex is closed. So the lowest point is 0, and similar to the domain, this arrow is going to the right forever, but it's also going up forever. So it goes to positive infinity, and close it out. And so that's my interval notation. My inequality notation, I have to write something is bigger than something else. And so in this case, again, I care about the y value. So in this case, all y values in this function, because it's going up forever as well in the vertical direction, so all y values that are greater than or equal to the lowest point. And in this case, the lowest point is 0. So y is greater than or equal to 0. So at this point, I found my domain and my range, and I am done. Okay? So I'm going to get you started on this problem. I'm going to help you find the vertex, and then I want you to practice finding the domain and range on your own before you check your work with mine, because this is very important that you master this skill. So, the vertex of my next function, again, is given here. I have to identify the h and k. And if you remember, I can draw a wall. In this case, there are two numbers paired with the x. There's an x plus 1 inside the radical and then a minus 2 outside the radical. The number inside the radical is my h. The number outside the radical is my k. All right? So if I write the vertex, inside the radical is lying to you. To the left is lying to you. Instead of positive 1, it's negative 1, comma. Outside the radical is telling the truth. Negative 2. Just like that. So the vertex is negative 1, negative 2. So I can plot that, negative 1 down to negative 2. And that's all I really care about for this. I'm going to draw a similar shape like what you see there. So it goes on forever like that. But the vertex is what I care about, because the vertex is going to help me find the domain and range. So the vertex, again, this is the x value, this is the y value. X value tells me the lower part of the domain, y value tells me the lower part of the range. So go ahead and pause the video and try to find the domain and range on your own. Alright, at this point you should have paused the video to try to find the domain and range. I'm going to show you how I would do it again, because again, finding the domain and range is very important. So for the domain, I have to include the leftmost point, and the leftmost point is this dot right here. This dot is negative 1 comma negative 2. We found that from the vertex. And so it makes sense then that the leftmost point is my x value of my vertex, which is negative 1. And then it goes on, again, this graph goes on forever in the right-hand side, so it goes on to infinity. Like that, and hopefully you're able to write the interval notation as well. This is the interval and the inequality notation. So x is greater than or equal to, not 0 now, but negative 1. Again, my x value of the vertex. So that's the domain. Hopefully that's what yours looks like. In the range, it's similar. I have to include the lowest point. In this case, the lowest point is still this dot, but I don't care about the x values anymore. I care about the y values for the range. And so the lowest, the bottom, the floor, is the y value. And it includes it because that dot is closed, so it's negative 2. And it still goes on and on forever in the upward direction as well. So it goes to infinity. And then the inequality notation, all of my y values have to be greater than or equal to, and again, or equal to because that dot is closed, negative 2. The y value of the vertex. At this point, I am done. So if your domain and range look like mine, that's great. If they don't, please rewatch the video and check your work, because that skill is very necessary moving forward. And please raise your hand if they don't as well, and I'll come talk to you about it.